So far is called explicit differentiation. Why? Because you have y equals, and you try and take the derivative of that. There's a lot of cases you can't solve for y, so you can't just say y equals and take the derivative. An example, you have this problem, y cubed plus y squared minus 5y minus x squared equals -4. Find dy dx. Notice there's nowhere on earth I can solve this problem for y. I can't. None of us. Now, what does implicit differentiation says? It says, well, you know, let's take the derivative of each one of them. Now, what's the derivative of y to the third? Well, it's not really 3y to the second, it's half correct. The derivative of that, 3y to the second, times, because you don't know what y is. You're not taking the derivative dy dx, dy dy. You're taking the derivative with respect to x. You don't know what that is, so it's times dy dx. Remember the derivative like u to the third, 3u squared times what? U sub prime. The same thing here, the derivative of y to the third, 3y squared times y sub prime, or dy dx. What's the derivative of y squared? 2y times dy dx minus, what's the derivative of 5y? 5 times dy dx. What's the derivative of x squared?
2x times dx.
Well, this will be 2x times dx dx, right? But what's dx dx? So we never put that in. And what's the derivative of any constant? So we take in the derivative with respect to x. So if you have a y, you're going to have dy dx. If you have an x, you're going to have dx dx. So you can see that's a 1, so I'm not going to put it in. So let's move this one to that side, and that becomes what? Positive 2x, and dx dx is 1. I can cancel it out. That's a 1. But let's look at this side here. What do you notice about them? Every one of them has what? Dy dx. So if I factor out dy dx, what's left? Dy dx times 3y squared plus 2y minus 5. Can we now solve for dy dx? This is a multiplication. What's the opposite to multiplication? Division. So we apply implicit differentiation when we can't solve for y. It's too difficult to solve for y. If you have y equals, there's no reason to use this method. Just go ahead and take the derivative. And notice my function, my derivative, depends on x and y here. Let me try another one. Oh, I need this slide. X squared plus 4y squared equals to 4. Now I could solve this problem for y. I could. Because if you want to solve for y, you take the x squared there. What do you have? 4y squared equals what? 4 minus x squared. And to solve for y squared, you divide everything by 4. And to solve for y, what do? Could be either plus or minus. Could be either one. The square root of that. Oh, 4 minus. Which, that 4 here gives me a 1/2 in the front. And actually, I can take the derivative of that. I don't want to do it this way. Implicit differentiation is easier. Now I'm going to take the derivative of that. Use the general power rule. So why not then do it? So now take the derivative. Using the general power rule. First, if I leave it plus or minus, I have a problem. Why? It's not really a function. Can't have, when x equals a number, you have two y values. That's not a function. You're going to use one or the other. So if I use the plus side, I go, okay, y equals positive. What's the derivative of that? Remember, this is 1/2. You can write that. 4 minus x squared to what power? 1/2? And what's the derivative of that? You go 1/2 times 1/2, which is what? 1/4 times what's inside the parentheses, times the derivative of what's on the inside, which is what? -1. Derivative of this is -1. -1/4. Oh, that's x. Oh, that's squared. I forgot the square here. That becomes negative what? 2x. I forgot the square there. I wrote it too tiny there. I can't even see it. You leave one little thing out. That little 2 here changes the whole problem. So, what's negative 2x times 1/4? Negative, is that x over 2? Or 1/2 x? 4 minus x squared to the -1/2. Or negative x over 2 times the square root of 4 minus x squared. So I could have solved the problem for y like what I did here and take the derivative. The truth, I don't have to. Let's see it the other way, implicit differentiation. Is that quicker? Let me write the problem down. Come on. Let's try with implicit differentiation. What is the derivative of x squared? 2x times dx, which is, I'm putting it right now just to give you a practice there. Always put dx there. But you don't need it. Plus this will be what? 4 times 2? 8y times what? dy dx equals what? 0. Move this one there. That's a 1. That's negative 2x equals 8y dy dx. Divide by 8y. Negative 2x over what? 8y. And that'll be negative x over what? 4y. Now that answer looks a little bit different. But wait a minute. What is y equal to? Isn't y equals 1/2 the square root of 4 minus x squared? From here? So if you plug it in, 1/2 the square root of what? 4 minus x squared. So what is your final answer? Negative x over 2 times the square root of 4 minus x squared. Is that the same answer? Same exact answer. So this particular problem, I could have solved it for y and, take the derivative of it. But a lot of examples, you really can't solve it for y. So that's your best way of doing it. It's called implicit differentiation. When
You had to solve it for y though to finish that problem.
Well, you don't have to. You can leave the answer in terms of y, actually. You'll see for the homework, they're going to leave. I'm trying to show you the answer is the same. So for the homework, they're going to stop right here.
Oh, all right.
You can leave your answer in terms of x and y. Because a lot of these problems, you can't solve it for y. Like this example. They want to find the slope of this problem, the slope. It says find the slope of the tangent line at the point 3 comma 1. 3 comma 1. What is that? Find the slope of the tangent line. Find the derivative at 3, 1. X is 3, y is 1. Even if you try to solve it for y, you can't solve it for y. You say, oh, I can multiply this one out. You know? You say, you know what? This is power of 2. Let's multiply it out. I don't have to, but let me multiply it out. If you multiply it out, what do you have? X to the 4th plus 2x squared y squared plus y to the 4th, right? So you multiply by 3, what do you have? I just made it worse. Could you actually solve for y? No way. So it doesn't matter if I leave it like this or like this. I can't solve it for y. So my approach is implicit differentiation. I can either do it here or do it for that one. Normally I don't do this extra step right here. So I can't solve it for y. That means, guess what? Implicit differentiation. That's your safe way of doing it. Implicit differentiation. And I'll start with the original one. I'll go back to the top. Never mind the multiplying and trying to simplify it and collect like terms and all that. Start with this one. I'm going to go back to the top. What is the derivative of this? Notice the power is different than 1. So which rule? General power rule. 3 times 2. 6 x squared plus y squared to what power? 1 times the derivative, what's on the inside? What's the derivative of x squared? You want to write dx just to practice? And what's the derivative of y squared? 2y dy dx. And let's stay with the left side. We'll go to the right side in a few minutes. If you distribute that, where'd you go? If you distribute that, you're going to have 2x times 6, which is what? Is that 12x? X squared plus y squared. What's dx dx? 1. 12y x squared plus y squared times what? I already did, nope, dy dx, right? 6 times 2y is 12y, and I'm leaving this one, I'm leaving that piece. Now, let's come back to the right side. You have 100xy. What does that mean? When you see xy, what does that mean? X times y, right? 100x times y. So what method are you going to use there? Product rule. This is f and that's g. So it's f times g sub prime. F times g sub prime. F is what? 100x times g sub prime. What's the derivative of y? dy dx. Plus g, which is y, times the derivative of 100x, which is what? 100. So I have to use the product rule. We have a multiplication. F times g sub prime plus g times f prime. Clean it. 100x dy dx plus what? 100y. And now we need to solve for dy dx, which means I want to take all the ones that have dy dx in them, put them on one side. All the ones without dy dx, put them on the other side. So let me bring this one to this side and take this one to that side. I'm going to collect like terms. If I factor dy dx, I'm low on red, I'll go with blue. The blue is low too now. If I factor dy dx out, this piece is going to have what? 12y times x squared plus y squared. When I bring that piece to this side, it becomes minus 100x. On the other side, you're going to have what? The 100y. When you take this one to that side, it becomes what? Minus? Oh. Can we solve for dy dx now?
It's going to be over, right?
Yep, it's a multiplication. The opposite to that is division. Over what? 12y times x squared plus y squared minus 100x. If they give you a point, you should write to the publisher says thank you. Because instead of plugging this equation now into that solution box, you can plug in the numbers and write one answer, a lot easier. So x is 3, y is 1. Plug them in. dy dx. What is 100 times 1? 100 minus 12 times 3, which is what? 36? Times 9 plus 1. 10. We'll come back and simplify it. 12y. Y is 1. 12 times 1? 12 times what? 10 minus 100 times 3, which is 300. So we have 100 minus 360 over what? 120 minus 300. Oh, I forgot to get a calculator here. Is that negative 260? Over negative, is that 180? The minus will cancel. 26 over 18, which you can divide it by 2, and that's what? 13 over 9. A lot easier to write this than to write that one. When we used to make our own exams, instead of me typing 4 answers on the test, I don't want to type 4 different answers like these. I always ask for the derivative at a point. This way I only have to write numbers. 13 over 9, 5, minus 7 over 4. A lot easier to write than to write 4 answers like this to type them. Especially when we had typewriters. Somebody sent an email today. We have a free typewriter. Who wants it? Not one reply. Still floating. So if somebody wants a typewriter, we have one on campus. They're trying to get rid of it. I'm like, oh, I think it has to stay on campus somewhere. Okay, let's try another one. These videos are going to be a little bit long today, each one. But George will go and mark them, don't worry. I saw your marks there all over, that's good. George actually goes through the video and he lets you know where each piece begins. So if you just go jump to that link there, because they all have access to it, right? Yeah. So you click on that, enter it, we'll jump to that spot of the problem, so you don't have to go drag back and forth. He goes and he marks every video and he puts his stuff there. Just look under the video, there'll be a link with his name there, his username, George, and just it says this example starts at 12:41. You click on that example, it jumps to that spot in the video immediately. Yep.
Makes it easier for me.
It does, and it would be nice if I can put them there, but I'm lazy, I gotta admit that. But he's doing for me so I can go and put them in. I said, that's too much work because it takes me 3-4, like today I won't leave the campus till probably 10:30 tonight. Just uploading the video, it takes a long time. Doesn't just happen quickly. And I want to do them from here, which is faster than my house. I do. Still a lot, well I have wireless all over the house. And Ethernet is way faster than wireless. Plus, I need my memory stick empty. Once I go home, I don't feel like doing it. I gotta say hi to my wife. I didn't see her since I left the house at 5:30 this morning. You know. Hello, stranger. Yep, hello, goodbye. Let's find the derivative here. The question was actually, I already jumped the gun. I know what I'm doing. The question, y equals, or sine of y, that's what the question equals x. You know what? Instead of wasting my paper, my eraser. The question was sine of y equals x. Find, I already jumped the gun, dy dx. So you have to take the derivative each side. That's what I start doing there. Should equal the derivative of the other side. What's the derivative of sine y? Cosine y, keep going, you're not done. Dy dx. What's the derivative of x? 1. To solve for dy dx, we divide both sides by what? Cosine y. What's 1 over cosine? Is that secant? But my gut feeling, it's just me, your book doesn't want to leave it like this. Because the book is funny. They want you to practice other stuff. So what are they going to do? Instead of this answer, they probably don't want to see cosine and sine. and what they might do. So that's correct there, but they don't want to see it that way. It says sine of y. That means you have an angle. Let's see if we can figure out what cosine y is. We have an angle called y, and we know the sine of it. The sine is x. Well, what is the definition of sine? What sides? Opposite over the hypotenuse. If the answer is x, that means x over what? No. No, if the sine is just x, can you write the x as a fraction? If it's just x, can you write the x as a fraction? X over 1. That tells you this is the opposite, x, and this is the hypotenuse. The sine is opposite over the hypotenuse. Can we find what the adjacent now? Because if we know what the adjacent, we know what the cosine.
1 squared minus x.
Yep, Pythagorean's theorem. Will be the square root. Remember, if we call this z here, you go 1 squared equals z squared plus x squared. Pythagorean's theorem. Bring the x squared to this side. What is z equal to? The square root of 1 minus x squared. And what's the cosine of y? The cosine is the adjacent, which is 1 minus x squared divided by the hypotenuse, which is what? 1, and that's equal to 1 minus x squared. Now come back and plug this one in, and that's probably what they want to see. I'm just guessing here. I'm trying to give you all these options because I have no idea how they want the answer written. So don't be surprised if they decide, you know what, let's write the answer like this instead of secant. This is the stuff actually that makes me like the software, because it forced me to do all that extra stuff. Try to get your math to be much better. Let's try another example here. Let's do a second derivative, implicit differentiation. Find the second derivative y dx squared. Let's find the first derivative first. What's the derivative of x squared? 2x times dx dx. Again, keep practicing. What's the derivative of y squared? 2y dy dx. What's the derivative of 25? Dx dx is 1. Negative 2x equals what? 2y dy dx. What's dy dx equal to? Negative x over y. That's the first derivative. Now we need the second derivative. That's the derivative of this. Well, what do you notice right here? What do you have? Fraction. So what rule should we use? Quotient rule. You can let f of x equals what? Negative x. And what's the derivative of that? Negative 1. Let g sub x equals y. And what's the derivative of that? That's 0. dy dx. So what's the second derivative now? We're going to use the quotient rule, which is g times f prime minus f times g sub prime all divided by g squared. G, which is y, times f prime, which is what? Negative 1, minus f, which, I saved the square brackets for the derivative. F, which is what? Negative x, times g sub prime, which is dy dx, all divided by what? Which is y squared. What's y times a minus 1? Negative y. You don't have to put the 1. It is true, negative 1, but you don't have to put it. What's minus times a minus? Positive x times...
Negative 1, right? Negative x. That one.
This one?
Right, negative 1.
Here?
Yeah.
Or here?
There. In the middle. Negative x.
Minus negative x. That's f times g sub prime.
That's negative 1, right?
That's negative x, f. Right? F times g sub prime.
Yeah.
So that'll be x times dy dx. But wait a minute, don't write dy dx. Why? Do we know what dy dx? We just get that answer, right? So negative x over y. The whole thing divided by what? Y squared. Now to get rid of that fraction here on the bottom, the quickest way, the easiest way, what do? Multiply by y, by y, by y. You multiply every term by the LCD, which is y. So what are we going to have? Negative y squared minus what? X squared over y to the third. Well, let's look at that. Let's try to finish it. Can you factor anything out? No, the top. How about a minus 1? If you take a minus 1 out, what's left? Y squared plus x squared, or x squared plus y squared, right? Now, why did I factor the minus 1 out? In case you forgot, let's look at the problem. What is x squared plus y squared equal to in the problem? 25. So replace that with 25 now. It says in the problem, x squared plus y squared equals 25. So now, that'll be what? Negative 25 over y to the third. This is the fun part.